I'd like you to welcome Alex.
Good afternoon, everyone. My name is Alex Watt, and I am grateful to share with you today. I've had the opportunity to go on medical service trips to Ethiopia a few times with my church, and today I'll be sharing about a Rails application that I built for those medical clinics. I realize this is the last talk before we have drinks, so thank you for hanging in there. And speaking of drinks, I have an important story to share with you. A little over 1,000 years ago, in Ethiopia, there was a goat herder named Kaldi. Kaldi was not extremely active on social media, but I did manage to find this photo on his Twitter account. This was before Twitter became X. As the sun was setting one evening, he noticed a few of his goats had found this tree with red berries. It was unusual for them to get this excited about food so late in the day. But they ate these berries, and they were so energetic, they began to dance. Kaldi knew that there was something special about this tree. He tasted the fruit, got a jolt of caffeine, and he was hooked. It didn't take Kaldi long for him and his friends to transition from mainly chewing on these beans to mainly brewing them. And we've all been drinking our morning coffee and our mid-morning coffee and our afternoon coffee ever since. That makes me wonder, how many of you enjoy drinking coffee? If it's you, would you raise your hands? And then would you keep your hands up if you make it at home sometimes? And then also if you sometimes grind your own beans? And then also if you sometimes roast your own beans and grind them by hand? So not too many hands are left on that one. So when I was in Ethiopia, I got to experience a different way of making coffee. A traditional Ethiopian coffee ceremony includes building a fire, roasting the beans over the fire, grinding them by hand with a mortar and pestle, and then brewing the coffee over the same fire. I got to see this multiple times. And they make 3 rounds of coffee. The first one is really strong, so you get it in a small cup. And the second one's a little bit weaker, and the third one you can share with kids. Sometimes they serve it with popcorn, and often they enjoy it with friends. Hospitality and slowing down are really big parts of Ethiopian culture, and I feel like coffee brings that all together. I was introduced to Ethiopian coffee in Addis Ababa, which is the capital of Ethiopia. I've gone to Addis 3 times, each for 1 week. Each time I've gone with a nonprofit, Ethiopia Act. Ethiopia Act was founded over 20 years ago in response to the AIDS crisis. In the beginning, they provided palliative care to people dying from AIDS because there was limited treatment available. As treatment became available, they developed techniques to help people take their meds on schedule, which the government and other organizations learned from. Today, AIDS can be managed, and Ethiopia Act continues to serve the underserved in Ethiopia with other kinds of care. For example, ACT helps many parents to find better jobs, which allows their kids to go to school instead of working. ACT provides holistic care for families they serve, physical, social, spiritual. In 20 years, over 2,200 families have become self-supporting and graduated from their program. The Ethiopian staff who work in Addis are serving families every day, visiting them, helping them to get medical care, providing social support, etc. One of the ways that volunteers help ACT is by serving on medical teams. Medical teams come several times per year for a week at a time. Each team has medical providers like doctors, nurses, physical therapists who provide direct care to patients, as seen in the photo. Medical teams provide care for beneficiaries of ACT, people that ACT is kind of committed to caring for. But they also provide care for the community, and sometimes that allows ACT to identify people who might benefit from the program. Non-medical volunteers like me can help in various ways, including in the pharmacy. The clinics have a small pharmacy so that most prescriptions can be filled immediately. Most medical team volunteers are from the United States, but over the last year, more Ethiopian doctors have been volunteering to help with clinics. In January 2025, I served with this team and worked on a project that I will now share with you. My church in Pittsburgh continues to send teams, and actually the next team is leaving on this Saturday to go to Addis. In 2024, ACT asked me to help with something. After each medical team left, the staff was sorting through hundreds of patient medical records on paper and creating reports. How many patients were seen, what were the top diagnoses, etc. The data was not very structured, and they wanted a way to consistently report on clinics each time that a medical team came. They saw some benefits from this structured data. They could set volunteer expectations. Very often a doctor who's volunteering says, what am I likely to see if I come and serve on a team? They can better plan for pharmacy. If they know the kinds of things they're seeing, they can stock the pharmacy. You never want to have too much stuff in the pharmacy because it expires over time and it's not always good ways to use it, but you also don't want to not have enough stuff and not be able to serve people. And then they can also understand community health over time. So sometimes ACT does interventions in community where they partner with an organization and do something in a region, and they would want to understand, they would expect that to show up in the data. So they'd like to see how the community health is over time. So since they asked me to work on this, the first thing that I did is I tried to understand exactly what they wanted. So I interviewed the staff, and I worked on writing a document to get us all on the same page about what problems they were trying to solve. That helped me work through some misunderstandings I had about their constraints and about their requirements, and it helped the staff to get on the same page about what they wanted. The requirements were coming from two main places. There was a US director who had some needs for different data that she wanted, and then there was the Ethiopia directors and people on the ground and their perspective and their on-the-ground needs. So I was kind of merging these together. And one of the things that became clear through the document was exactly what data we wanted to collect. So essentially there's two important data models. There's the clinic, which has a date and a site. So it might be the Akaki neighborhood in Addis and a team like the Pittsburgh team. So that makes up the clinic. And then there's a number of patient encounters associated with the clinic. Each encounter has an age, and we joke that in Ethiopia, the age is sort of a fluid thing. People are never quite sure sometimes the age, it just depends. But age, gender, beneficiary, whether they're already attached to ACT as a beneficiary or not. And then some data like the diagnoses that we noticed and the referral categories. So this is the core of the data that we wanted to be able to collect. I really hope to be able to take these requirements and then look at some options and find something that would be a great fit for the organization. So after the trip in January, I spent some time working with the ACT team to look at some options throughout the year. Unfortunately, we didn't find a compelling choice. I'm going to walk through some of the things we looked at. The most compelling one was called Backpack EMR. So this is a medical record system designed for these exact situations, mobile medical clinics. And so it seemed like it would be a great fit. We had a couple conversations with them. We ended up running into a couple of challenges. The first one was that they were hosting their data outside of Ethiopia, and based on the ACT staff's understanding, we would need to keep the data in Ethiopia because of some personally identifiable information and Ethiopian regulations around the medical records. And this vendor could not figure out a way to host it. Also, the reporting was a bit limited, and they had a different philosophy on reporting where any reports that we wanted to build, they would have to build for us, and we couldn't export raw data in any way, even kind of stripped of PII. So there was just some differences in understanding about this, but the main reason we didn't move forward was the data residency issue. Another option that we considered was a Google Sheet. I mean, this would have been great. It would have been free. People know how to use Google Sheets. There are some challenges, though, working with relational data in a Google Sheet, the amount of validations you can do. Some of the integrations we wanted to build on top, I think, would have been harder with a Google Sheet, and permissions are just less existent. There's less control over these things with a Google Sheet. The third option I was pretty excited about was called OpenMRS. So this was an electronic medical record system that's open source, designed for low resource settings like this. Again, seemed really powerful, but it also seemed non-trivial to deploy and customize. It seemed like this gorilla that we would be pulling in all this stuff, and then we only need a subset. We really had pretty basic data gathering requirements. So I was kind of frustrated after the year of looking through this stuff, and I thought, should I be building an app for this? But I also didn't want to bite off more than I could chew or commit to anything too big. I knew whatever we did had to be a relatively simple solution. So when I thought about maybe building something, the stack that I went to immediately was Rails 8 and SQLite. So I've been building with Rails for over 15 years, so I'm really familiar with Rails. And I had a chance to work with SQLite extensively at work for a couple of years, and I felt like I was just really impressed by how simple SQLite is. And for this use case, low data volume, it would be a single app server, it seemed like it would be a really perfect fit. My only hiccup here was I was thinking, I don't want to build a front end for this. I'd like to figure out what's the current state of how I could build a front end for this Rails app. So in the past, I've done things like Twitter Bootstrap and other things, so I started exploring. I was really hoping for something very simple for building this, because I do not want to maintain the front end code, ideally. So about a week before the trip, I was doing research, and I found this tool called Avo, which is a Rails gem for building internal Rails apps. And it had everything I needed. And it would allow me to focus on those features I was building out and forget about CSS, JavaScript, HTML. And Avo is a sponsor, so definitely recommend checking them out. So with this tech stack, I was able to get something working in a week. And I'm not claiming there's nothing fancy here, right? But I'll just kind of walk you through the week and what we were able to do. So Monday, generated a new Rails app. Tuesday, finished up the data models, like the data models I showed on the previous slide. On Wednesday, I got it deployed. I used Hatchbox, which is a tool for doing Rails deployments where you let Hatchbox control your servers, and then you kind of in a Heroku style push your code, and it handles the deployment for you, handles managing the servers. And I liked the way that this would allow us to change server providers over time in Ethiopia, for example. On Thursday, I got the user policies all worked out because I had a couple different user roles, and I launched it so we could start entering data from the week. And then on Friday, I started getting user feedback as people started trying to use us on their phone, entering stuff. There were UX things to fix, but it was quite valuable to start getting their feedback. So now I've said a lot about the app without showing it to you. Let me show you the dashboard. So this is the dashboard that the team is able to see during the week. They can see how many patients they've seen. They can see the volume by day. They can see the top diagnoses. We're using a standardized list of diagnoses, which I'll talk about more in a minute, and some other stats. Now, as somebody who had been on teams before, teams would always kind of wonder, like, how many people are we seeing? What are the top diagnoses? And there's different doctors, and they're seeing different things. So it was cool feedback for the team to be able to see what was going on. So the project impact was a few things. Volunteers were able to help with medical data. In the past, we handed a stack of records, and another team on the ground would enter it in the weeks to come. Also, the data was a lot more standardized. They had some issues with the standardization of how they were reporting, and this app solved for that. Medical teams could see their impact, and future teams were better prepared, like I mentioned about the pharmacy and helping providers to know what to expect. So far, we've documented just shy of 1,600 patient encounters in 5 different neighborhoods in Addis, and that'll keep growing even next week. So as I think about this app, I wanted to share a mental model that I got from Dan McKinley. Dan has a great article called Choose Boring Technology. And in this article, he basically says that when you're building stuff, you want to prefer known technologies, the boring ones, because you know where their strengths are and where their weaknesses are. But he doesn't say you should never do anything except the boring and known stuff. He says, maybe you should consider that you have an innovation token budget. So every bet that you make, every new technology you adopt that hasn't been proved yet, that's going to cost you an innovation token. And maybe a team should consider that they have like 3 tokens to spend. I felt like on this project, I was able to really conserve my tokens. I used Rails, which I knew really well. I used SQLite, which I was quite comfortable with. Even Avo didn't feel like a risky bet to me based on the tinkering I had done with it. I would argue that looking back on the project, I spent one innovation token, and I spent it on search. So I'm going to show you why the out-of-the-box search with Avo wasn't a great fit for our use case. We had a list of over 20 diagnoses, like groupings of categories of diagnoses, and they were things like this: neoplasms, diseases of the blood, endocrine, nutritional, or metabolic disease, et cetera. So we're taking a provider's very specific diagnosis, and we're mapping it into these categories for the reporting purposes. That's hard to do. First, it's actually sometimes hard to read doctor's handwriting. That's one thing. But even if once you figure out what it says, then you have to map it into one of these standard categories. And even if I knew what it was, I have to scroll through like a list of 20 things. Or my wife, she would take the thing and she would type it into the app, and she would be like, it's not returning any results. Like, it didn't match exactly one of the keywords here. So I knew I needed to come up with something better for search. So in the end, I had a search system that ran entirely on a server, no other dependencies, which I'm really happy about. And you could type in a medical term like this one, and you would get back the correct category. So in this case, there's like a long word I don't know how to say. And then the result is diseases of the musculoskeletal system. And if I were to Google that, I could double check. In fact, this is the right category. So I want to talk about how I did this and why I did it this way. So over the years of building applications, I've learned to be very cautious about external API dependencies. Vendors come and go. They change their APIs. And every new dependency introduces headaches down the road in my experience. Whether it's them going out of business, their API going down, whatever, it's just more headache. I wanted to minimize this. So I thought about what I wanted out of a search system for searching diagnoses. Basically, I wanted this hybrid system that was twofold. I wanted semantic search based on the meaning of what we were typing in, and it had to include enough medical knowledge that you could put in these very specific medical things and find it. I also wanted fuzzy matching, so if somebody misspelled something, we would still find the closest result. So what do I mean by these two things? If I had a query and I put in the word fizzy as an example, semantic search would bring back results like sparkling water, soda, these are fizzy drinks. And fuzzy matching would bring back things like frizzy hair, which is like a slight typo over fizzy, or fizzy's diner, something like this. So for the semantic search part, I found that I could use a Hugging Face model. This machine learning model was published there, and it was a sentence transformers model. I used a Ruby gem called informers, which allowed me to plug the model into my Ruby code. And then I was able to get the embeddings, and I was able to build out the semantic search. And I'm going to talk more about that on the next couple slides. On the side of fuzzy matching, I used an algorithm called Jarrow-Winkler, which is really common. And these were good fits for my use case, and the way I implemented them worked fine. I had a small list of diagnoses, so I did not build any indices for this. I did not need those because I had such a small list of 20-somethings. So the specific model I used for the embeddings, and an embedding takes a text, takes tokens, and it turns it into a vector space. So you have an embedding, a vector, a series of numbers, and it represents the meaning. Two vectors that are near each other in the vector space are closer in meaning, ideally, than two vectors that are not close together. So this model was 91 megabytes to download, and it ran fine on my application server. I didn't have a lot of load or anything. I had one vCPU and 1 gigabyte of RAM. I was able to get search results back in under 100 milliseconds, which was fine for my use case. So let me walk you through some code for this. I used the informers gem to instantiate an embedder. I passed in the exact model that I'm using. I made a small function, an embedding function that just invoked the embedder, and then it turned the array into a vector. So vector is a Ruby class that I discovered from this project, and it's easier to do these mathematical operations if you are using this Ruby representation. So when I did cosine similarity, that was quite useful. Then I needed to embed, create embeddings for all the diagnoses. So I map over the diagnoses, and I use the diagnosis name plus the examples, feed those into that embedding function I showed you, and now I have a pair of the diagnosis and the embedding. When I did this initially, I always try the most simple thing first, so I tried embedding the name, and it never occurred to me that the name wouldn't be enough, but it was not enough. When I was doing search and I just embedded the name, it didn't work great. And so I started taking the examples. We had those parent categories of diagnosis, and then a list of maybe 5 or 6 example diagnoses underneath of that. It worked a lot better. So putting the examples in made the embeddings more relevant. So the next step was I needed to embed a query. So I read the docs for the sentence transformer model, and it says to put this prefix on. I don't know exactly what the prefix does, but I did it anyway. It says represent this sentence for searching relevant passages. So if you put this prefix in, and then you put your query, you get an embedding that you can use to search through the space. And then this slide kind of brings it all together. So now I need to do search with both the embeddings and the fuzzy text matching. So again, because there's 20 of these, I can do this very naive technique. I just loop over the diagnoses with filter map, and I compute 2 scores. One is the semantic score, telling me how close in meaning the query is to the diagnosis that I'm thinking it could be a match for. And the second is the fuzzy score, which is based on that Jarrow-Winkler algorithm that's telling me, based on what the user has typed, is it close in terms of edit distance to the diagnosis we're considering. Then I throw these diagnoses out of the set unless it meets a threshold for the semantic score or the fuzzy score. And I just tuned this by experimentation. There was nothing fancy for tuning this. Although you could use an evaluation set, and there's fancy ways of doing it, but this was fine. And then I take the top score, and I had normalized these scores in some way so that they were comparable. And I sorted the results by score, and now I had a list of up to 3 diagnoses. Now let me show you briefly how the search is integrated in the rest of the app. So here's the patient encounter form built with Avo. I did minimal customization of Avo. Basically, I asked, after I did this project, it was much later, I just asked an LLM to pull colors out of the logo of Ethiopia Act and restyle Avo. And that's basically all the customization I did. It worked great out of the box. So here's the form for entering the patient data. You put in some demographic information, and then you can click a button to attach diagnosis, and this brings up that full list. So if you want to, you can read through the list, but the search after this iteration worked pretty well. So you can type a query in and find the relevant category. So now I've described what I worked on, I want to share a few things that I think you could take away from this talk. The first one is pretty personal. I hope it's not come across as offensive, but this is just based on how you guys showed with your hands earlier. Your coffee ritual is probably weak. I imagine some of you wake up, you drink your morning coffee, and you're not feeling as energized as you'd like, so maybe you could try, build a fire, roast the beans, grind them by hand. If it doesn't work, let me know, figure something out. More seriously, I think it was really valuable that I got something working end-to-end as soon as I could, working on this project. I think we've all had projects that we were excited about doing, but then time gets away from you and you don't manage to get something working end-to-end. I'm really glad that I found a simple enough approach to get something shipped in less than a week, even though it lacked polish. And I was embarrassed a little bit by the first version, especially the one with the terrible search. But I'm so glad I got it working. I was able to present a prototype midweek, make sure we were on track. Launched a version, worked out some kinks while I had my time off still on that Friday, shipping a few improvements. And then I was able to iterate on the search later and improve it before the next medical team came. Getting something working end-to-end in a thoughtful way means you can iterate on each component later. I'm not saying that you should slop something together to get it working as soon as possible, where you might not lay the right foundations, you might have to rip them out later. But if you can figure out the right components, you can build a system in a thoughtful way where you can iterate without having to redo everything. Another thought is that simple software is a really good thing. Sometimes as engineers, we're basically just plumbers, and that's great. We should keep things as simple as we can. When I was a kid, I wanted to be a software engineer someday, and I dreamed that I would build all kinds of complex systems. But now that I'm an engineer, I know that complexity is not the goal. Simplicity is the goal. Our goal is to take complex problems and figure out how to solve them simply. We should never be embarrassed to talk about our simple solutions. We should be proud of them. And when our systems are complex, we should be looking for ways to simplify them. Another takeaway is that open weight models are awesome. Open weight is to models what open source is to software, roughly speaking. You can take an open weight model and you can run it on your own infra. It is so magical to run AI models locally. All of us were using things like Claude, ChatGPT, these things, and we're sending our data to another company and they're running inference on their side. But if you can get a model that's small enough that you can run it on your laptop for development, it's just really powerful. And I felt like it was just an amazing thing to pull that model down and run it locally and iterate. So if you've never tinkered around with one, I recommend that you do. Go to Hugging Face and poke around at the data sets that they have and the models that they have, and also check out that Informers gem. We can't let the Python people have all the fun with data and AI. There are ways to run these things inside of Ruby. And my last takeaway is that you can just do things. The world is a malleable place. There are all kinds of ways you can use your gifts and skills as programmers and creative people to help the people and organizations around you. If you want to go deeper on any of the topics in this talk, the link, acw.sh/act, has the resources, some additional links, it has the slides. I would also love to hear from you. I'm happy to chat. My email address is on that page too. Thank you for your attention. So all that's left to say is thank you, and in Amharic, Amase Ganalu.